An 84 maybe, but not an inspired.
Actually, they're always
It's for the 8. Alright, so let's look at the properties of definite integral. What do you think the value of this would be if I go from A to A? What would it be? 0? Okay, so if you say 0, we think of it graphically, right? We're trying to find the bounded space from A to A. Am I moving? No, so is there going to be any bounded space? No. Okay? And we could also justify it by applying the fundamental theorem of calculus, and we're going to say the antiderivative of this is the capital F. So we would get capital F on the top limit A minus capital F, the antiderivative of the bottom limit A, which we know is what? 0. You understand? That's the algebraic view. The second property is telling us that if I have some number C in between the interval A and B, and I want the integral from A to B, so I want to go from here to here, okay, how could I do that another way? Because let's say it wasn't differentiable at some point in between them. How could I split up that interval to be able to evaluate the whole thing? Very good. So this would be like me going from A to C, right? And adding whatever I get from C to B. Does it make sense? To get to here, right, I could split it up and say from here to here and then from there to there. Still getting the whole thing. You understand? Number 3 says, if the integral from A to B of f of x is equal to k, then what do you think the integral from B to A is going to be?
Negative? Negative k.
Negative k. Okay, why would it be negative k?
Yeah, just opposite direction.
The other one was like f of b, right? Minus f of a, and we got a positive number, right? So if I switch those numbers, right, then I should get a what? The opposite of it, right? The negative of it. Okay. So in one case it was going from, let's say, left to right, and then the other one it went from right to left. So you got to remember that, okay? We always want to go from the smaller limit to the bigger limit, from left to right. Got it? That's kind of what this next one is saying. If b is smaller than a, so if I have a smaller number up here than I do on the bottom, right, then we know that that's going to be the same as the negative of the integral from b to a, putting them in the right order, the small number on the bottom and the big number on the top. Alright, so take notice in that. I put a negative there, but I also did what with these guys? I switched them, okay? Because I always want to have the smaller limit on the bottom and the bigger limit on the top. Okay? What did we do yesterday on problems like this where we had a constant times the function length? We could take the constant out, right? So we could say k times the integral from a to b of f of x. And just work it out like that. Alright, how about number 6? If I had the addition of two functions within the integral. How could I do it? Could I just what? Very good. Separate it into two integrals, right? So the integral from a to b of the first function plus the integral from a to b of the second function. Plus or minus, right? Whatever's happening there with it. Good? And the last two are going back to pre-cal where your teachers talked about even and odd functions. Do you remember those?
Yeah.
Yes, when was a function even? Like that one right there is an even function. How could I tell it was even just by looking at the graph? Very good. Okay, even functions will always be symmetric with respect to the what? To the y, okay? If you wanted to check by hand, what you would do is you would change the value or the sign of the x and you should still get the same y value. So when I plug in A, I get some Y, and when I plug in negative A, I better get what? The same Y value. You remember doing that back in pre-calc? Okay, so an even function, remember, is symmetric to the y-axis. Okay. That means it's split up into two parts. And if we're going from negative A to A, right? This area here is going to be what compared to this area? Equal, right? Okay. So going from negative A to A would be the same as going from 0 to A how many times? Twice, right? So we could say that this is equivalent to 2 times the integral from 0 to A of f of x. Or we could also say that it's 2 times the integral from negative A to 0. The main thing to remember is that they're going to be what? The same value, right? Good? What if something's odd? Symmetric with respect to the origin, right? What does that mean? Because it's kind of weird.
Oh, to the origin.
Symmetric
Oh, the origin.
with respect to the origin? Okay, so that means that it reflects over x and y, and you get the same graph? So like if I flip this over the x and then over the y, would I get the same picture? Yes. Okay, algebraically what we would have to do here is change the sign not only of the x, but also of the y, and end up with my original function that I had to begin with. I don't know if you remember doing so. Okay? Right. So what do we notice is going to happen in this case when I go from negative A to positive A? We're going to have some area or some space here that's positive and some other space over here that's negative, and they're going to be equivalent to each other. So what should the answer be there? 0, okay? So remember that when they're odd, whatever goes from 0 to A is equivalent from 0 to negative A, but it's going to be what? One's positive and one is negative, they will cancel each other out in this. Pretty cool? Alright, ready to apply these properties? Think you're going to remember them? Let's give it a try, okay? So there will be some problems on the test where they give you an integral already. Here they're saying from 0 to 3 is 6, from 3 to 7 is negative 8, and we need to use the properties to find the other ones. So the first one says from 3 to 0. So what should that equal?
Negative integral of 0 to 3.
So this is equivalent, right? This one's from 0 to 3, but they switched them, right? So it's the negative of 0 to 3 f of x, which we know this guy is what?
Negative.
6, so my final answer is what? Negative. Cool? The next one wants us to go from 0 to 7. Hi.
Add the inner. You get negative.
Okay. Okay, great. I had them do it themselves, but I guess we can use this to double check.
Yeah, thank you.
Thank you, ma'am.
Negative 2. Yes,
All right, how about from 0 to 7? I don't have something that takes me directly from 0 to 7.
Just add the inner.
I got from 0 to 3 and 3 to 7, right? So we could say that this is equivalent from the integral from 0 to 3 plus the integral from 3 to 7, right? What is it from 0 to 3? 6, and from 3 to 7?
Negative
So what do we end up with?
8.
Negative. Good? Try the next one, from 3 to 3, what's that going to be? 0, very good. How about from 7 to 3? of 3 times f of x. Make it negative, so, because these guys are gonna switch, right? So negative, and then what else? Can we take out the 3?
Yes.
And then we're gonna go from 3 to 7 of f of x. We know that this guy right here is how much? Negative 8 times that negative 3 that was out there gives us
24.
Papitas?
Yes.
Alright. Let's look at 7. From 3 to 7 of 2 plus 3 times f of x dx. What could we do on this one? This is kind of like the property right here, where you have two things being added to each other. So get the integral of each, right? So we can say the integral from 3 to 7 of just 2 with respect to x, plus the integral from 3 to 7, maybe we should have taken out that 3, right? Times f of x dx. Okay? We know this guy right here was how much? Negative 8 times that 3, right? And that's going to be added to the integral of 2. What's the integral of 2? 2x, right? We've got to find its antiderivative. And evaluate it from where to where? From 3 to 7, right? Okay? Because we don't know anything about that guy because it wasn't described up there at the top. But we can find its antiderivative. So plug in the 7, what do we get? 14 minus, plug in the 3, 6. So all of that is what this is equal to, minus 24. What do we end up with?
Negative 16.
Negative 16. Good job. Just like yesterday on some of those problems we did, there was a number there, right? You had to remember that you need the antiderivative of that number, put that 2x there. Same idea here. Right. The next one is telling us that f of x is an even function. What does that mean? Symmetric to the y, right? Okay? So that means what's on one side from 0 is the same as what's on the other side from 0, right? So sometimes what I do on these problems is I draw a little number line, and we're going from negative 3 to 3, and we know the midpoint has to be 0 because that's the part that cuts it in half. That's the y-axis, right? Okay. What integral do we know that's given at the top? We know from 0 to 3 is what? 6. So from here to here should also be what? So my answer to this guy should be what? What? Because we wanted to go from negative 3 all the way to... You understand? If they said it was odd, then this would have been 6, but this would have been what? Negative 6, right? And it would have ended up giving us what? 0. We could have also thought of it like this, right? 2 times the integral from 0 to 3 of f of x. Either way works. Some kids do better with the little visualization. How about the next one? What did they tell us? It's an odd function, right? So again, we're going from negative 3 to 3, and we got that origin there, that's 0. We know from 0 to 3 it's what? 6. How much is it going to be from negative 3 to 0 since it's an odd function? Negative 6. So if I combine them to go from one to the other, we would get what? Easy? Let's come up with a random problem here in this little square since I already know. So suppose that the integral from 3 to 6 of g of x is equal to 7, and the integral from negative 6 to 3 of g of x is equal to 12. So this is the information that's provided, all right? I want you to find the integral from 0 to 6 of that function g of x. if I tell you that g of x is even? How do you want to attack this one? You want to do the little number line thing? Or you can just figure it out yourself. Maybe we should do the little number line? So if I draw the number line, it's going to be from where to where? Not 0 to 6. From negative 6, right? All the way to positive 6, right? What's in the middle? 0. Is there anything else that I know? I know 3 to 6, so that means it must be split up here, and I should also have what over here? Negative 3. Now let me put the numbers of the things that I know. I know from 3 to 6 is what? 7. So if that guy's 7, who else is 7? Negative 6 to negative 3, right? Because we said it was what? Even, right? They also told us that from negative 6 to 3, so from here all the way to here is how much? 12.